Hello students, this is your chemistry teacher. Today we will be discussing on some important questions of group 16 elements. So let's get started. First of all, the first question is, which of the following does not react with oxygen directly? Zinc, titanium, platinum, iron. Okay, so among these four metals, we know that platinum is a noble metal. The rest metals like zinc, titanium, iron are quite reactive. And for this reason, platinum will not gonna react with oxygen directly. Moreover, platinum is very thermally very stable, right? That's why platinum is used as ornaments, or in ornament purpose we can use platinum, right? uh, Zinc, titanium and iron can combine with oxygen directly to form their corresponding oxide, but platinum will not gonna react with oxygen, and hence platinum will not gonna react with oxygen directly, but other metals can react with oxygen, forming their corresponding oxides. Now let's come to the second question. Complete the following reaction: C2H4 plus oxygen. This is the first reaction. Second reaction, aluminum plus oxygen. Okay, so in case of first reaction, what is going to happen when C2H4 is combining with oxygen? It will form carbon dioxide with the liberation of water. It's a basically it's a uh, combustion reaction of hydrocarbon C2H4. It's a basically C2H4 is basically a hydrocarbon, right? So this hydrocarbon will be participated in oxidation, or in combination with oxygen it will form carbon dioxide with the liberation of water. Moreover, in case of aluminum, when it will react with oxygen, it will form a amphoteric oxide, that is aluminum oxide, Al2O3, right? Now in case of third question, the question is H2S is less acidic than H2T. Why? This kind of questions we have already faced in chemistry of group 15 elements questions. They are also same type of questions were there. Here the thing is, as the size of the element central atom uh, is in this compound H2S, central atom is sulfur, and in this compound H2T, central atom is tellurium, right? Now as the size increases from sulfur to tellurium, the bond length of this bond is this MH bond. If I say this bond as MH bond, where M represents either sulfur atom or the tellurium atom. So as the size of the central atom increases, the bond length of this bond increases. You can see over here that the bond length is increasing here from in this compound, then this compound. In case of tellurium hydrogen bond, this bond is longer bond than SH bond, right? So if this bond is longer bond, if this tellurium hydrogen bond is longer, obviously we can expect that this bond strength will be very less. And if the bond strength is less, then this hydrogen or this proton can easily escape from this compound in the form of proton, right? And for this reason, this compound H2T will show a greater acidic character in comparison to the molecule H2S, where the bond length of this SH bond is shorter, and for this reason bond strength is higher, and for this reason hydrogen is not gonna leave this compound H2S. So for this reason the H2Te is more acidic than H2S. Now let's move on to the next question. The question is, why is H2O is a liquid but H2S is gas? As far these hydrides H2O and H2S are concerned, we know that H2O exists as liquid state in normal temperature and pressure, and H2S exists as a gas, right? In case of H2O molecule, the oxygen is very much electronegative atom. Moreover, we can say that oxygen is the second most electronegative atom or element in the periodic table, right? So in case of H2O, there is considerable amount of bond polarity that is present in this molecule, because oxygen is more electronegative. That's why a del negative charge appears on the head of oxygen and del positive charge appears on the head of hydrogen atom, right? So here the water molecules that exist as liquid state, where bond polarity is a very good factor, where oxygen is negatively charged end and hydrogen is positively charged end, and in this way the charge develops in these elements oxygen and hydrogen, help this water molecules to be associated with one another by hydrogen bonding. because this hydrogen, this del positive end of hydrogen will be connected with del negative end of oxygen, and this del positive end of hydrogen will be connected with the del negative end of oxygen through hydrogen bonding, right? And due to this hydrogen bonding, due to this hydrogen bonding, or due to this intermolecular hydrogen bonding, H2O exists as liquid state. Whereas in case of H2S, there is no such considerable amount of bond polarity present in case of sulfur hydrogen bond. Though you can say that sulfur is itself an electronegative atom. Yes, it's true, but this electronegativity of sulfur is not in that level to create a intermolecular hydrogen bonding like water molecules. And for this reason, as bond polarity is very much less in this H2 in this SH bond, right? And for this reason, the intermolecular hydrogen bonding is not possible in case of H2S. In case of H2S, there is no such intermolecular hydrogen bonding present. But in case of H2S, the H2S molecules are connected or are attracted by weak van der Waals force. Okay, and as we know that van der Waals force is very weak force, that's why the H2S gas molecules are firmly associated, uh, are hardly associated by one another by this van der Waals force. And for this reason we can say that yes, the H2S exists as a gas, not in the liquid state, because uh, there is no such intermolecular hydrogen bonding uh, in case of like water molecules present in the H2S molecule. In H2S molecules, only weak van der Waals force is present, that is not sufficient to make this H2S uh, exist as the liquid state, and for this reason H2S exists as the gas state. Now we are going to discuss the question number 5. So what is the question number 5? Which forms of sulfur is paramagnetic in nature? So first of all, in vapor state, sulfur exists as S2 molecule, which contains 2 unpaired electrons in the antibonding molecular orbital. So if I explain this, suppose it is a sulfur atom, one sulfur atom that has the electronic configuration 3s2 3p4. So there are 6 electrons in the valence shell, and this is another sulfur atom that contains the same electronic configuration, that means 6 electrons in the valence shells. So all total in S2 molecule there are 12, there will be 12 electrons. Okay, so these 12 electrons of S2 molecules will be distributed in the molecular orbitals in the following way. Here you can see that these are the molecular orbitals: sigma, sigma star, pi, pi star. These are the molecular orbitals, and here the 12 electrons are distributed in this way: sigma 2h2, sigma star 2h2, sigma 2px2, pi 2px2, pi star 2px, pi star 2px2. Sorry, this will be pi star 2px. Sorry, this is pi 2px2, pi 2py2. This is pi star 2px1 and pi star 2py1. Okay, so here you can see in each molecular orbital there are 2 electrons. Okay, but here in pi star antibonding orbital, that means pi star 2px, that contains an unpaired electrons, and pi star 2py, this antibonding orbital, molecular orbital, contains an unpaired electron. So due to the presence of these 2 unpaired electrons that I have marked in blue color, due to the presence of these 2 unpaired electrons, S2 molecule is paramagnetic in nature. Okay, now let's move on to the next question. Elements of group 16 generally show lower value of ionization enthalpy compared to corresponding periods of group 15, right? So why you have to explain this phenomenon? So first of all, group 15 elements has the electronic configuration ns2np3. There are 5 electrons in the valence shell, right? And in case of group 16, the electronic configuration is ns2np4, right? So there are 6 electrons in the valence shell of group 16 elements. Now in case of electronic configuration of group 15 elements, you can see that there is a half-filled, stable half-filled set of orbital, that is np3 orbital, that is a half-filled orbital, and half-filled orbital is very stable, right? So in that case, if we want to take out one electron from group 15 elements, I have to take out the electron from the more stable half-filled p orbital, np3, and that is very quite a difficult process, right? So high amount of energy is needed to remove one electron from group 15 elements, and that's why higher ionization energy is required to take out electron from this group 15 elements. Whereas in case of group 16 elements, less amount of energy or lower ionization energy is required to take out electron from the relatively less stable np4 orbital. Okay, so for this reason group 15 elements exhibit a higher ionization energy than group 16, because in group 15 there is a half filled set of half filled p orbital, that is quite stable orbital, very stable orbital, and that's why higher ionization energy is required to take out electron from group 15 elements. Okay, now let's move on to the next question. Why does ozone act as powerful oxidizing agent? First of all, ozone is an allotropic form of oxygen that actually decomposes spontaneously to give you O2 and this oxygen. This oxygen is a special oxygen atom or special form of oxygen that is called nascent oxygen. This nascent oxygen is very much reactive. Reactive in the sense it can oxidize the substances easily and forms the corresponding product. Suppose if I allow a reaction like if I consider the reaction like lead sulfate with ozone, then lead sulfide, sorry, so this lead sulfide will be oxidized by the nascent oxygen of ozone and it will be converted into lead sulfate, okay, with the liberation of O2, where lead sulfide is oxidized to lead sulfate and ozone is being reduced to O2, right? So if we take another example of oxidizing property of ozone, that we can show that if I take iodide solution that contains I minus ion, and if I pass the ozone gas, okay, then what would happen? What is going to happen here? Here ozone will oxidize the I minus to I2, right? And at the same time ozone will be reduced to O2, right? So this reaction also proves that ozone is a good oxidizing agent, and this is due to the nascent oxygen. Now let's move on to the next question. Are the two sulfur oxygen bonds in SO2 structure are equal? You have to prove it that if they are equal, then how is it happening? Okay, now first of all, what is the structure of SO2? SO2 has a bent structure, as you all know. The SO2 has a bent structure where sulfur is the central atom and it is connected with two oxygen atom by double bond and a single bond, and these are the two resonance form where you can see that SO2 molecules, this sulfur oxygen double bond, the sulfur oxygen bonds is sometimes a double bond and sometimes a single bond, and this is due to resonance, right? And for this reason we can think of a actual structure of SO2, that is this is called the resonance hybrid of SO2 molecule. Okay, so in the resonance hybrid you can see that the sulfur oxygen bond is neither a purely a single bond or a purely double bond. It is in between single and double bond, because it is that in the resonance hybrid both the single bond character of sulfur oxygen bond and the double bond character of sulfur oxygen bond is present, right? So that's why sulfur oxygen bond length, if we calculate, we would find the sulfur oxygen bond length as a intermediate bond length between single and double bond length. Okay, and that's why these two sulfur oxygen bond become equivalent, and they will have a similar bond length, and that is the intermediate bond length between single and double bond length. Okay, so the two sulfur oxygen bond in SO2 are equivalent and they have the same bond length, and this is due to resonance. Now, how is the presence of SO2 is detected in a medium? Suppose you have a medium where sulfur dioxide is present. You don't know whether it is present or not, and you have to prove it. Whether it is, if it is present, you have to prove it. So what you have to do, you have to take the medium that contains sulfur dioxide and you have to add some permanganate solution that is violet in color. Permanganate solution means KMnO4, that contains MnO4 minus as anion, right? So this violet color of permanganate, whenever it would react with sulfur dioxide, it will be converted into colorless solution of manganese 2 plus, because sulfur dioxide is a good reducing agent, right? So I have already explained it, right? So SO2 is a good reducing agent. That's why SO2 will reduce this MnO4 minus to colorless manganese 2 plus. It is a reduction process from MnO4 minus to Mn2 plus is a reduction process, right? So SO2 will reduce this MnO4 minus to the colorless form of manganese 2 plus, and at the same time it will oxidize itself to SO4 2 minus. Okay, so SO2 is a good reducing agent, and for this reason SO2 will change the color of permanganate solution, of violet color permanganate solution, to colorless manganese 2 plus solution. And if we observe the color in the reaction, then we can we would be sure that yes, in the medium sulfur dioxide is present. Now, what are the condition in the next question? What are the condition to maximize the yield of H2SO4 by contact process? We have already discussed the contact process that contains several steps, right? So you can check this out in that video, right? H2SO4 preparation of H2SO4 by contact process. In the contact process, the most important, the key process, the key step is this step, is the production of sulfur trioxide SO3 from sulfur dioxide SO2. This is the key process, this is the key step in the total contact process of a preparation of H2SO4, where sulfur dioxide is being oxidized to sulfur trioxide using a catalyst. You have to use a catalyst like that is V2O5, vanadium pentoxide. So in this reaction, as you can see, that delta H for this reaction is negative, minus 196.6 kilojoule per mole is the delta H of this reaction. That means this amount of energy will be released in this process. That's why delta H is negative. So as we have already learned in Lassatier's principle, that in case of exothermic process, if we maintain the temperature very low, the reaction will be in the forward direction, will occur in the forward direction. So that's why for this process, for making this process a successful process for preparation of H2SO4, we have to maintain the temperature as low as possible, right? At the same time, if you can see that here in the left side, the total number of moles is higher. There are 3 moles of reactants are present, 2 moles of SO2 and 1 mole of O2, right? And there are 2 moles of SO3, 2 moles of product are present in the right side. So obviously we have to maintain the pressure of the reaction very high. That means because according to Lassatier's principle, high pressure, if we maintain high pressure, then reaction will try to proceed in that direction where the pressure would be less, and the pressure is less in the product side, right? Because in the product side, number of moles of product is less in comparison to the total number of reactant. Total number of reactant is 3 moles, total number of product is 2 moles, right? So if we increase the pressure, if we maintain the pressure high in this reaction, then the reaction will occur in the forward direction, because in the forward direction the product pressure is less, product gas pressure is less. And that's why low temperature and high pressure, these are the two important conditions that have to be maintained throughout this process of preparation of H2SO4 by contact process, right? So low temperature and high pressure. Another important thing that we have to look on, that we have to keep the temperature of the reaction not very low. Okay, if we maintain the temperature very low, then obviously the very low temperature will affect the kinetics, will affect the rate of the reaction, and it will make the rate of the reaction very slow, and that's why the H2SO4 preparation of H2SO will be hampered. And that's why we have to maintain a low temperature, but it should not be very much low. We have to maintain a low temperature and high pressure for the production of maximum amount of H2SO4 by contact process. Okay, now let's move on to the next question. Why is Ka2 is very less than Ka1 for H2SO4 in water? As we know, H2SO4 is a diabasic acid. Okay, so H2SO4 contains 2 protons, and it would dissociate in water as, in the first step, it would dissociate as H plus and HSO4 minus. This is the cation and anion that are formed in this first step. And in the second step, the HSO4 minus that is formed in the first step would be decomposed into SO4 2 minus and H plus. So dissociation constant for the first step is Ka1, and for the second step is Ka2. As we know that dissociation constant indicates the extent of dissociation, or indicates the extent of forwardness of a reaction, right? So this the dissociation constant Ka1 and Ka2 are indicating how much these species H2SO4 and HSO4 minus are being dissociated in these processes. So if the value of Ka1 and Ka2 are higher, then we can say that process is the process is occurring in a faster rate, and decomposition will be faster. And if they have low value, then the process would be slower and the decomposition would be slower, right? Now experimentally it has been observed that the value of Ka1 is much greater than Ka2. What is the reason behind it? Reason is very simple. Because in the first step, H2SO4, a neutral species, is giving you H plus and HSO4 minus, while in the second step, HSO4 minus, that is itself a negatively charged species, that is giving you a di-negative charge, SO4 2 minus. So obviously the formation of a dinegative charge from a negatively charged species is a very difficult process, because chemical substances always try to avoid to create a charge, right? And that's why the process of production of SO4 2 minus from HSO4 minus, okay, would be very difficult process, and that's why the decomposition of HSO4 minus will be very slow. And for this reason the value of Ka2 will be very very less than Ka1. And for this reason we can observe that whenever we used to calculate these values Ka1 and Ka2 for H2SO4, we used to find that the value of Ka1 is much greater than Ka2. Okay, so these are the most important questions of group 16 elements. Hope you have understood all the topics. Thank you for watching this video. So this is all about some important questions of group 16 elements. Hope you have understood all the logics. The rest questions of the next topics will be coming up in the next week. Thank you for watching this video.